Hi everyone, and welcome to our group discussion on waste management. Our main goal for today is to discuss on how analytical technique help in the identification and management of waste. My name is Safra Cheda, and I'm with Akira, Afira, Alia, and Rika. So today, I will be moderating our session today. The goal of our discussion is to highlight the role of analytical chemistry in addressing waste related with challenging. Let's begin with Atira, who will walk us through the introduction and problem statement.
Thank you, Jaida. Based on the literature I have reviewed, waste management refers to the process of collecting, transporting, processing, and disposing of waste materials in a way that reduces their impact on health and the environment. It is especially crucial now due to the growing volume and complexity of waste, particularly hazardous and electronic waste. Many of these wastes contain toxic metals or harmful organic compounds, which pose serious risks if not properly identified and managed. One of the major issues is the limited use of analytical tools in current waste management systems. Without proper chemical analysis, disposal methods may be unsafe or inefficient, especially in urban areas, where waste is generated in high volumes. Rika, can you explain more about why the global waste situation is considered alarming?
Thank you, Atia. That's a great overview. To add on, the current global waste situation is quite alarming, and in many countries, waste is not properly segregated, landfills are overflowing, and illegal dumping is still widespread. And we are also seeing increasing levels of microplastic and persistent organic pollutants in soil and water sources. And this shows that managing waste isn't just about collecting it. We need detailed chemical analysis to understand that we are dealing with and to manage it effectively.
Exactly. That's where analytical chemistry plays a key role. It helps us determine the chemical composition of various waste materials. This includes detecting heavy metals, organic pollutants, and even trace contaminants. Techniques such as gas chromatography mass spectrometry (GCMS) and inductively coupled plasma mass spectrometry (ICP-MS) allow us to accurately identify substances in complex waste samples.
Yes, and there are other important tools too. For instance, Fourier transform infrared spectroscopy is used to identify types of plastic, while X-ray fluorescence provides rapid screening of metal content. These methods are crucial because they help determine how waste should be treated, whether it can be safely recycled, incinerated, or need special containment. They also assist in environmental monitoring, such as checking for toxic leachate in landfills or harmful emissions in the air.
Great point! Now, let's look at the real world case to better understand the application. Rika?
Okay, sure. One well-known example involves e-waste management. And in places like Guyu, China, and part of India, improper recycling without any chemical analysis led to widespread soil and water contamination due to lead, mercury, and other toxic elements. And however, with proper analytical technique, companies are now able to identify hazardous components in electronic waste and process them safely. And this helps reduce pollution and allow for metal recovery, which adds economic value. Another case involves using chromatographic technique to detect organic pollutants in landfill leachate. And this ensures the water draining from landfills doesn't contaminate groundwater sources.
Thanks, Rika. In the discussion of findings, analytical data is essential. For example, if a sample of industrial waste shows high concentration of heavy metals, we can use that data to determine the toxicity level and recommend the proper treatment, like containment or recovery of metals. These techniques don't just identify the problems, they help authorities and industries take informed scientific actions. That is why analytical chemistry is considered as a backbone of modern waste management.
That got it really well. In summary, analytical techniques are crucial in managing waste effectively. They allow us to identify hazardous substances accurately, determine safe treatment method, and support environmental protection efforts. Without this tool, waste management would lack precision and could lead to the greater environmental and health risks. Before we end, I would like to highlight two key recommendations for our discussion. First, promote greener technologies in waste analysis and treatment. Using eco-friendly and energy-efficient tools can reduce the environmental impact of waste processing itself. Second, increase public awareness through education. When people understand the dangers of improper waste disposal and the benefit of analytical approaches, they are more likely to support waste segregation, recycling, and safe disposal practice. These combined efforts, scientific, technological, and educational, will help us in achieve a more sustainable and responsible waste management system. Thank you everyone for your excellent contribution today.
Thank you.
Thank you.
Thank